Hello everyone, in this lesson let's see what are perfect squares. So perfect squares are the product of a positive integer multiplied by itself. So let's see what it means. 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, 4 times 4 equals 16, 5 times 5 equals 25, 6 times 6 equals 36, 7 times 7 equals 49, 8 times 8 equals 64, 9 times 9 equals 81, and 10 times 10 equals 100. So this 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100 are known as perfect squares. It is because the product of a positive integer multiplied by itself is giving us this number. Suppose 2 times 2 is giving us 4, 4 times 4 is giving us 16, 5 times 5 is giving us 25, and so on. And this 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100 are known as the first 10 perfect squares. Now let's see why 9 is known as perfect square. So when we draw a square, this 9 can form a square perfectly with whole number side lengths. So it has 3 units of side lengths and an area of 9 square units. Likewise, all other perfect squares like 25, 36, 49 can form a square perfectly with whole number side lengths. That's why these numbers are known as perfect squares. Now let's go through a technique to see if a given number is perfect square or not. And this technique is called prime factorization, which is to factorize everything into prime number. So let's take some example. Let's say we have 20. Is this a perfect square? To see this, we need to factorize this 20 into prime numbers. So this 20 can be written as 2 times 10. Furthermore, this 10 can be written as 2 times 5. Now let's see if all the factors has a pair. This 2 has a pair, but this 5, it does not have a pair. So that's why this 20 is not a perfect square. Let's look at another example. Let's say we have 400. 400 can be written as 4 times 100. This 4 can be written as 2 times 2. And this 100 can be written as 10 times 10. 2 times 2. This 10 can be further written as 2 times 5, and same with this one. So now let's see if all the factors has a pair. This 2 has a pair, this 2 has also a pair, and this 5 also has a pair. Since all the factor has a pair, therefore this 400 is a perfect square. Now let's see if 500 is a perfect square. 5 times 100 is 500. 5 times, I can write this 100 as 10 times 10. 5 times, furthermore, I can write this 10 as 2 times 5, and same with this another 10, 2 times 5. Now let's see if all the factor has a pair. This 5 has a pair. This 2 also has a pair, but this 5 right here, it doesn't have a pair. Therefore, this 500 is not a perfect square. So now let's see if 625 is a perfect square. I can write this 625 as 5 times 125, which is 625. 5 times, I can break this 125 as 5 times 25. So 5 times 5 times, I can further break this 25 into 5 times 5. So now let's look at the pair. this 5 has a pair, and this another 5 also has a pair. Since all the factor has a pair, therefore this 625 is a perfect square. Now let's see if 1200 is a perfect square. 1200 can be written as 12 times 100. This 12 can be written as 4 times 3 times 100 can be written as 10 times 10. This 4, it can be written as 2 times 2 times 3, and this 10 can be written as 2 times 5, and same with this one, 2 times 5. So now let's look at the pair. If everything has a pair, this 2 has a pair, this 2 also has a pair, and this 5 has a pair, but this 3 here, it doesn't have its pair. Therefore, this 1200 is not a perfect square. Now let's look at 1600. Is 1600 perfect square? Let's see. 16 times 100 is 1600. I can write this 16 as 4 times 4, and this 100 as 10 times 10. I can write this 4 as 2 times 2. Same with this one, 2 times 2. The 10 can be written as 2 times 5, and same with another 10, 2 times 5. Now let's see if everything has a pair. 2 has a pair. This another 2 also has a pair. This 2 right here also has a pair, and this 5 also has a pair. Since all the factor has a pair, therefore this 1600 is a perfect square. There is one interesting fact on perfect square which says that numbers ending with 2, 3, 7 and 8 are never perfect squares. So let's see what it means. Is 42 perfect square? It's not perfect square because it is ending with 2. Is 4, 4, 8, 2, 5, 8. Is this perfect square? It is not a perfect square because it is ending with 8, and we need not do any sort of prime factorization to check this. Is 5, 0, 2, 5, 2. Is this perfect square? It is not perfect square because it is ending with 2. 3, 4, 3, 4, 3. Is this perfect square? It is not because it is ending with 3. Let's look at another fact on perfect square which says that all even powers of 10 are perfect square. What does it mean? Let's say we have 10 raised to 2. Is this perfect square? Yes, it is perfect square because the power of 10 is even. Let's say we have 10 raised to 8. Is this perfect square? Yes, it is because the power of 10 is even. 10 raised to 15. Is this perfect square? It's not perfect square because the power of 10 is odd. Let's say we have 10 raised to 19. Is this perfect square? It's not perfect square because the power of 10 is odd. Is this perfect square? Yes, it is because the power of 10 is even. So this is all about perfect square. I hope this lesson helps you all.